Oh, never knew how hard it gets, rude old boy. Yeah. Mhm. Boys, what's up? What's good, man? Let me hope you guys are doing great, doing cool. Today is day 3. We're not stopping until
Three.
we assure something great, something good. So that said, let's see what next I gotta do here. I was missing out AirPods 3 Pro. What is that? After all, I'm amazed that I conquered these. Oh, oh. Mhm, mhm. Do not switch anything. All right. Oh, never knew how hard it gets, real dope boy. After all, I'm amazed that I conquered these. Yo, you play chess? I do. I do play chess. I do play chess, my brother. What's up? You wanted to try me or something? Yeah, I do play chess, my boy. Hold on. What's your rating? My rating? I'm rated 2000. 2000 elo. Just 2000 elo only. Oh, I came out. What's good? What's good? What's good, my brother? Trying to get everything locked together. Yeah, 2000, bro. Let me show you. Uh, call my bluff right now. Call my bluff. Let's see. Just give me a sec. Real dope boy. How can I? All right. I think is there a way where I can read the chat without? Now let's see here. We'll pop that. We've popped that. Whatever. I think this is cool like this. All right. So I just want to close the chat off now. Good. And then I can open this in like theater mode. All right. So I think everything is cool now. You know, I'm not capping, bro. Why are you saying cap, bro? What's your problem? What's your problem? Can we have a match 30 minutes later? Yeah, yeah, we shall. We shall. That's what I do though. Like I first do some coding, some DSA and all that, and then we play some chess, like, you know, just to refresh the brain and then get back to coding again. IK Mouse, call my bluff, bro. Call my bluff right now. You saying it's cap. Come see it for yourself. See my rating for yourself, bro. See my rating? 2000 rated player. Stop playing with me. I'm not 2K, bro. I'm not 2K like that. I just play. So I started playing the game. I think when I joined December. I don't even. I think the time I joined was, I was just on stream and I didn't even like play since then up to maybe just 1 month ago. So I have 1 month playing now chess, which is nice. Yeah. But just give me your name. I mean, my name is here. You can just look me up and add me as a friend, which I'll play afterwards. So let's see what we're gonna be doing today. Yesterday we did this maximum. We did this hourglass problem, and we understood it in both lead code style and also in hackerrank style. So as you can see, in hackerrank style is not as direct, but it is just the same idea actually. It is the same idea. The only difference is that if you look at the lead code one and the HackerRank one, is that lead code, HackerRank, they actually take in they read the actual input and output from the stream, from the buffered reader, as you can see. But for lead code, they just use the actual function. So the only difference is that for HackerRank, it is super fast because it just reads everything from the stream, right? You don't need any extra function or whatever. So that's the only difference. But other than that, everything is just similar. So as you can see here, we are using grid.length minus 2 and then grid.length minus 2, but in position 0 because we are dealing with J. So I think it's the same thing. Here we have the outer loop. which is going to loop through this hourglass. We are considering this kind of hourglass, if you guys are not getting the image. This is like we want to calculate the highest number that forms an hourglass between all these numbers. So this entire matrix, it's a 6 by 6 matrix, right? It's a 6 by 6 matrix. So that means we can create this first hourglass starting from 6 up to 1, and then from 1 up to 9, and from 9 up to 8, and from 8 up to 6 again. So this is like hourglass kind of stuff. If you look at, I don't know if you guys don't know the hourglass, but if you know the hourglass, then you know what I'm talking about. And also from here, we can create another hourglass. Let me just change the color. It's starting from 2 up to 3, 3 up to 2, and then hold on, yes, 2 going to 7 as well, and then here it's still going to be an hourglass, right? Fair enough, I think. Yes, considering the hourglass, we are going to remove these two numbers. That's the reason why we are saying -2. I think you can see here we are saying -2 both sides. So that's the only reason, because the hourglass is looking like this. That means anything that is within this box here, or these coordinates, or this grid, we're not gonna worry about them, right? And if we are taking this green hourglass, we are not gonna take 5, and we are not gonna take 2. We are only taking 1. And here, this hourglass, we are taking 2. So that's the only thing, because we are starting from up here. And from the question, as you can see, if I can go to the description, you can see that note that an hourglass cannot be rotated and must be entirely contained within the matrix. As you can see, we are not rotating the hourglass. It should just be contained within the matrix. So this format A, B, C, D, we don't consider these two numbers. And then E, F, G, that's what we are considering. So I think that is all, my boy. That is all. Let's see what else. For this one here is just 1 hourglass. This is a, you watch Neat Code? I do. I do watch Neat Code. This is his. Actually, I'm watching this Neat Code 150 from Destination Fang. I watch Neat Code as well, but this guy explains these concepts very thoroughly, to the point where you get them. Like, and I like his style. He uses Java too. That's just an added cherry on top, because I use Java, and anybody that uses Java is already my friend. You feel me? I don't like anybody who doesn't like Java. You get it? So we beefing if you don't use Java. I watch him on Python. I don't watch Neatcode for the reason that he uses Python, and Python is trash. Python is super rubbish. Python is not a language. It should just be a scripting language. It's not any good language. I don't care what nobody says what. All right. So, boys, we need to speed up the game, bro, because like the interview is knocking on the door. You feel me? We have 10 days to go. So I need to get my shit together before. That's why I'm just trying to like do my best with these problems. So we are following NeetCode.io, the roadmap from NeetCode. So let me just show you guys the roadmap so far. I've completed most of the stuff. If you look here, I've completed arrays and hashing. I've completed the stack, and I'm now in 2 pointers. So after 2 pointers, I can go for binary search, sliding window, and linked list. So I'm just gonna do only these ones, and then I can be ready for the interview. I don't think they will ask anything to do with trees and all that. Like, I really doubt for like, I doubt it, they'll ask all of that. So I'm just gonna do these ones for now, and I'll be interview ready. So whatever they do, they better bring what I've read. All right, boys. So that is that for this. The only concept here is that we need to start with the minimum value, because we are going to be taking negatives, right? For lead code here, they are not considering negatives. So we are okay with starting with 0. We can even equate this to like 0 direct. We can say 0. And I think we shall be perfectly fine. Let's just run this and see. I think this will run, yes. But if we go to HackerRank, you'll notice that HackerRank, they're starting with like negatives as well. So that's the only reason why we have to start with integer dot minimum value. So this minimum value starts with like, I think is a number like -2 to 23. Yeah, I think it's like negative 2 to 23. The value of integer. I think the same value, integer dot minimum value. Oh, you do DSA in Python. I agree. But I want to go ML. So instead of choosing Java for DSA, JS for development and Python for ML, I skipped Java. Yeah. I think for me with time, I'll also want to try ML as well. Like I really love to just like let machine learn from what I like. I have a lot of things, I have a lot of ideas that I want the machine to learn from, you know? So I think with time, I'll also try to learn Python, but not right now. I have no interest in Python right now. So we're gonna say mean value. And this value, yep, this mean value is also the same as negative 2 to 23. I don't know if this is correct. Let's hope it's correct. I think this is that value, right? The least value that you can get out of the integer. I think. So let's see. Let's see. That's not our concern for today, right? Today we are going to be doing 2 pointers, and we are going to uh, twosome. But we are going to do the valid palindrome first. Okay, we're going to do the valid palindrome on stream. I have it here, everything figured out. But at the end of the day, I didn't do it with you guys on stream. So yeah, I might just do it on stream. I already submitted my solution. But it's good to have it again on stream so that it can stick in my mind, because that's just the best way to go about it. So, anyways, as you can see, we have a valid palindrome, and they're saying a phrase is a palindrome if, after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward alphanumeric characters include letters and numbers. Given a string S, return true if it's a palindrome or false otherwise. Now, we have an input that looks like this. I'm just going to select all of these and then see how we are going to do that. Right, let's grab this. Just gonna extend this here, paste this, and boom, we have this input. For some reason, why is it so bulky? Okay, bro, why are you so bulky? Calm down. Dang. All right, so we have this input here, and we're going to consider an output just here. We're going to say the output should look something like this. Now, how is this going to be a palindrome? Let's say a word or a phrase is a palindrome if it reads the same backward or forward, right? When you read it from going forward, it is the same as reading it coming backwards. Like the word Panama itself, it's not a palindrome because it doesn't start with A. So Panama is not a palindrome by itself. But this entire phrase is a palindrome. Let's see how. Now we have a case saying that we need to remove alphanumeric characters. Now, what are alphanumeric characters, right? It's just a fancy word of saying remove all numbers and all this other stuff. I think we are saying the things that are non-alphanumeric, right? Let me read it properly. You're converting all this into this after removing all non-alphanumeric characters. So non-alphanumeric characters, it means they are not alphanumeric, right? They are not alphanumeric. So I'm just gonna take all this and say alphanumeric. Alphanumeric, I think this is it. The alphanumeric characters are from A, which is capital A, small a, up to capital Z and small z. And also 9, 0 to 9, these are alphanumeric characters. Anything outside of this is not alphanumeric. So let's look at what we have here. We have things that are not alphanumeric, like for example, the spaces here, these gaps here. So let's just replace them with empty underscores. And also this, we're going to replace them with empty underscores since they are not alphanumeric. And let's just replace this with this. See how it goes. And also this, let's replace it like this. And we'll see how it goes. Hey, bro, what's that name? Cricket? Cricket Tanyalysis? Cricket Tanya. What? What's that name, bro? Cock? Cock Chicken Tanalysis? I want to join you in live, but my English speaking is trash. Where you from? Where you from, brother? Where you from? Okay. Where you guys from, bro? Let me know. Let me know where you guys are from. All right, let's look at the alphanumeric characters and then we take off the ones we've already taken off the things that are not alphanumeric, right? So, what else should we? I think these gaps we can even remove them, but I just included them so we can just have a bigger picture of what we have. So, if we now read this backwards, right? Let's try to read this AMANAP, right? The first character starts with A. I mean, the first character starts with capital A. The last character starts with small a. They are not the same. They are not the same. So what we're gonna do, as you can see from the question is telling us after converting all uppercase letters into lowercase letters. So that means we need to convert anything that is uppercase into small case. So let's do that. Lowercase. Let's also convert this to lowercase p. Then that means wait, bro. I'll responsive you. Yo, what? What kind of English is that? Cricket is a sport mostly popular in Asia. Yeah, mostly in India actually. I've never had other people play cricket apart from Indians, but maybe they are there though. But yeah, it's popularized in India. So now let's try to check again. The first character is A. The last character is A, and if we read this AMANA, we're also gonna have AMANA. Wait. AMANA. AMANA. Hmm. P L P L A N A N. You see that? A oh my god. This word is a palindrome, dog. This word is a palindrome. So we're gonna return true. After removing all of the alphanumeric characters and converting so I think the first step we need to understand the steps, right? The first step is to convert. Step one, convert to lowercase all characters to lowercase letters to lowercase. After that, remove all. Step two, right? Step two, we remove all alphanumeric characters. We remove all alphanumeric characters, and then after that, we return. What is this? Remove three. Okay, let's take step three. Step three, we return true. Yep, this is check, right? Yup. Oh my god. So we check if palindrome. No, we check and return true or false, right? Accordingly. So I think that is all we have to do. My internet is so laggy. I'll join you later, my brother. All right, man, no problem. Go have fun. Go have fun. Go have fun, my G. So let's go. Let's go ahead and try to increase this a little bit. All right, then I think the first thing we're gonna do is I think here now we can go with the brute force solution, right? If we look at this, we can go with the brute force solution and then just decide to convert everything from here, like what I said, what I did already here with the brute force. We first convert everything to lowercase. After that, we remove all alphanumeric and then check and return true or false. Now, what we are doing here is going to be I'm Real Ahmed Mughal. So check my YouTube channel now. It's called Cricket Analysis Team. Oh, okay. Because of what the extension that you built. Oh, I see. Oh no, hold on. You didn't build an extension. Real Ahmed Mughal. Oh, you're the one. I forgot. You from Pakistan, right? Yeah. Mm, yeah. Okay, so let's try to go and run that. Instead of that, we're just gonna use 2 pointers, right? And the 2 pointers that we are going to use, the 2 pointers will just be like this, right? We shall have, I think, a word here. Then we have, let's say, pen. Let's grab left pointer. I think let me change the color to like maybe pink. This is the only colors, I don't know. So we put the first left pointer and right pointer on the last word. It's so thick. I mean, okay, that's fine. So we're gonna have a left pointer and right pointer. So we're gonna have a right pointer and left pointer. Now we check for the position. If we just count, I mean, if we check this entire word here, we look at this and then we just loop through this entire word, and every time we check this character, we want to skip anything that is like non-alphanumeric so that we don't have to waste time like looping through everything. So we are going to come here. Is this alphanumeric character? Yes, that's an alphanumeric character, so we're going to keep it here. We're going to also loop through the right. We keep incrementing. I think for this we are incrementing the left, right? We increment the left pointer and we decrement the right pointer every time. So now what are we going to do again? We remove this from here and then we'll put it on the next word. I message you to get motivation because you work so hard. I truly like your channel, brother, from the bottom of my heart. Thank you so much, bro. Like, thanks a lot, man. For real. Like, thanks a lot for sure, bro. You know what's funny? I think I'm covering the entire chat. Let me just put my face this side. This is covering the chat. Let me just delete this. Delete this a lot as well. And let me put my face all the way here. I don't know if it will make sense for me to be all the way here, but let me can I just transform this flip to the right? I think flip, wait, hold on. Flip horizontally or vertically? Let's see. Oh my god. Where did I go again? Okay, I think it's horizontally. Yes. So now I'm facing this side, which is cool. I think, yeah, so I think this is like the actual correct side because this is my left, this is my right. So I think it's cool. You guys get the point. Let's continue. You guys can now yeah, man. Thank you so much for that, man. I think yeah, I think you guys can now see like your charts and all that. But yeah. So we move to the next word. The next word will be M. So we go through this entire thing. We don't find anything that's like non-alphanumeric. So these are all alphanumeric. Then we go to the next one here. Soon as R reaches here, if we reach here with R, oh, this is non-alphanumeric, skip it, and we continue moving until when the left pointer and the right pointer, they will meet somewhere in the left, I mean in the middle. And then if we return everything here, and then this one reads the same as this side, then that means this is a palindrome. So that's what we're gonna be doing. Let's see, start with the left pointer. It's going to be 0. We are starting from 0. And the next one is going to be the right pointer. Now the right pointer is funny because we need to consider the length of the string so that we can get the end of the string. I mean, wait, how do you get the last element? Oh, we subtract by 1. Okay, so we're gonna get that. Since it's a string, we're gonna have to add this method thing because strings don't have strings. I mean, s dot length. If these were numbers, we'd just say s dot length and it's fine. But for strings, we are just gonna leave it like this, and then we say -2, -1 actually. Yep. What am I saying? Okay, so that is that. Now we need to get a while loop and say while the left is less than the right. Right, I think that is it. While the left yep, while the left is less than the right, now we continue moving. Here we need to get some things together. All right. We're going to have another while loop again, but this time this while loop is just going to let's run this, press this. While left is less than right, and now we need to create a character. We need to create a character. How are we gonna get the character? Yeah, we are going to say, and this is not character. Is that a spelling of character? No. Character dot is letter or digit. Yep. So this is how we get like alphanumeric. Are you currently doing an internship? No, 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 no. I am just prepping for the interview. So it is going to be soon. Hopefully 10 days from now, we shall start the internship interview. And if we get that job, I don't know what I'm gonna do, but hope, let's just leave it up to God. You feel me? Let's continue going. So the digit you're gonna say mm, S, since it's a string, so we can easily get the character. So we're gonna say character at left, right. That is that. And we are going to now increment the left, like what we've been doing, right? Let's see. I think that's the same thing we've been doing. Yes, we increment the left, we increment the right, and then we do the same thing for the right. But for right, we are decrementing the right. So if left is less than right and the character is not alphanumeric, right? I mean, it's not alphanumeric since we are dealing with non converting all yes, non-alphanumeric characters. You feel me? But if they wanted us to remove alphanumeric characters, then we just remove that. So this one makes it non-alphanumeric character. So this is going to be right. And then let's see, we decrement the right every time by uh good. And then from here now, this is where we are going to just have character C. I mean, we can call this L since it's the left one. We're going to say character on the left. That's what we're going to be considering. So we shall just say character, character dot to low, since they're telling us to also convert them from after converting all uppercase to lowercase. So we need to convert this to lowercase. And what are we converting to lowercase? We are converting character on the left and on the right. So let's just grab the character on the left, and that's going to be the left character. We grab this and we go ahead and grab the right. We just call this the right, and this is going to be character on the right. And after that, we are just going to check if left is not equal to the right. If the left is not equal to the right, then we return false, right? Or else we just return true, right? So that's it. From here, we return false if the left is not equal to the right, or else we just we continue incrementing the left, and we continue decrementing the right. And after that, out of this while loop, we just return true if we don't get any false answer. So there you go. I think if we just try to run this right now, it should work perfectly fine. Yep. And what else can we do? Can we try to submit? See what's gonna happen. Good. We've beat 99% of the people. This is crazy. 2 milliseconds. We are not occupying any extra space because, yeah, the time complexity here, time complexity, TC is going to be O of n, and SC, which is space complexity, is going to be O of 1. And I think we are good. This is constant space. This is O of 1. We are good. We are not creating any other like string and any string to hold, because the brute force would be creating a string using a string builder and just working your way up from there. You understand? But at the end of the day, I think we are good now. We are now left with like the two-sum problem. These two-sum problem. This should not give us headache anyways, right? If we look at our NeetCode 150 roadmap here, We are done with the valid palindrome. This is the last one we're gonna do. This is a two-sum problem. So I think we should try to do it on neat code first, then we can go and do it on lit code, or we can do it on lit code and then do it on neat code. Because yeah, that's the way I like to do it, just to have like practice going. Okay. Yeah. So this number is kind of tricky. I'm not gonna lie. Um, two-sum problem. Hmm. Two-sum two input array is sorted. So input array is already sorted. Given a one index array of numbers, that means we are starting with one. Oh God, this number is gonna be hard. This number is gonna be hard, boys. Oh, this number is gonna be hard, bro. Oh my God. Can we try to do it? Oh, we first refresh our brain with some chess. I think we should refresh our brain with some chess. Then we can go back again and play some game. So let me just play. I don't know if you guys. There's somebody that was trying to play with me yesterday. Wait, this is the guy called Chicken. Is that the same dude? Or this Akash? I don't know. I don't know. Let's just try to play a game real quick on chess. Let's see. I'm playing somebody who's 372. Hmm. Let me play some Italian game. I see if it's gonna cook me. Wait, why is it a 15 minutes game? I was supposed to play a 10 minutes game. But let's see. That would be a good break though. That's nice. After all of the days that I conquered days, I think I'm covering this, right? My face is covering that, so let me just put this somewhere here. Yeah, I think I don't know if I'm covering like the entire stuff. Let me just do make it smaller. Just put it somewhere here. What did dude play? He took my stuff. He took my pawn. I was supposed to. Oh, this is actually not good. So why would you play like that, brother? Why would you play like that? Because now I'm gonna play some crazy game of this guy. I want him to just move away with this. Matter of fact, I think I am going to just take this pawn. After taking the pawn, I just pray he takes this away. Because if he takes this away, it's gonna be over. Oh, disconnecting. Why are you disconnecting from the game, brother? Let's get a free win anyways. I'm in my final year, and my FIU final year project is an AI-powered mental health app. This app takes tests for patients with depression and anxiety and provides the best advice. It gives daily guidance. Wow, that's a nice thing, boy. That's a very, very good thing. Is it like, yo, bro, remember me? It's been months. Last year I went out from office after they gave me React project. Wait. You left your job because they gave you a React project? No. Let me first answer my boy Rail Ahmed Mughal. He said something nice. He's like, he spoke about his project for depression. Bro, I would like to use that up too, because at some point I was depressed, bro. And depression is real. I don't care who says what, bro. Life is hard, and certain times you'll go through certain things that you just can't avoid. That's just life. But at the end of the day, there's always a reason to stay alive. There's always a reason to be happy. There's a reason to smile. And yeah, bro, I feel like your app idea is something nice. If you're willing to help people, then people will be willing to help you too, which is nice, right? So keep going, my brother. Just let me know when you finish your application. I'll definitely try it out. My boy said he said something. Oh, we got a free win. This is nice, bro. I'm not gonna lie. So let's just go ahead and change this to like 10 minutes game, because 15 minutes game is long. I just change it to a 10 minutes game so we can just have some thinking going. Nah, I didn't after they told me you have to do all the slow solely. They tortured me. I mean, they handed me React project. Um, they had a React project, but in half an hour they asked, "Did you finish it?" Yo, what? That's crazy. That's crazy. That's crazy. Why would they do that, bro? Why would they do that? I'm playing Karakan defense. Why would they do that, bro? That's so unnecessary of them. Okay. Let's get that going. I was supposed to just push this, bro, but like, damn, it's fine. Just protect this spawn and open the center. Um, I don't know what he's trying to play here, but I have no idea. All right, let's just play like that. So now I'm able to take this without him reacting to it. Nice. A few months before you heavily few months before you heavily spent time on backends. What happened to that? Why didn't be your own sauce? I finished it actually. I finished my entire sauce, man. Hey, one thing I want you guys to do, like when you jump on stream, the first thing you should do is just like the stream, because it just helps push the stream more. It just supports the channel as well. Just like the stream. That's all you gotta do. Um my application is done. It's called daddybucket.shop. You can check it out. You can check it out, definitely. It's called daddybucket.shop. There you go. Why is it in light mode? Let's just go to system. It is here. It's done. You can log in, log out, and all that. So let's see what this guy played. Okay, he played. Why did he play like that though? See what he wants to do. Long message don't show very well on YouTube. That's why it bothers me. For real, I don't know. I don't know. Like YouTube, I don't know why YouTube have like some bad UI. Like they literally have bad UI. I don't know why, bro. They're supposedly a $1 million company that have bad UI. I don't understand it. I swear to God, like if you go to the dashboard just looks funny. Like they have a bunch of bugs. They have a bunch of bugs like in their application, and it's just alarming, bro. Like to say the least. It's so alarming. Yeah, it's crazy. Oh my God. Let's see this guy. What is he trying to target? Is that not a problem? Because what if I play check here? He's already defended with the queen though. So what is he trying to target really? I can always just take it back. So it is what it is. What I'm gonna do, just gonna push this pawn. Yeah, let me just push this pawn. How did you feel after spending time with us? Wait, what do you mean by that? Is that a chat GPT wrapper or something? Why don't you have a donation or something in your page? Just asking, but it's not a chat GPT wrapper. I don't build chat GPT wrappers. For some reason, I don't build chat GPT wrappers, brother. And what's going on? Why is he trying to threaten me? Oh, he's trying to like create some checkmating ideas. But brother, are you sure about that? Are you sure about the checkmating ideas? Because I feel like I want to sacrifice this, right? I want to sacrifice this. Or maybe this. Yes, like this. Yep. Yup. Yup. So now let's see. Let's see what next from here. Let's see what next from here. Oh my god. Wait, did I blunder? Did I blunder anything? I think I did not blunder anything. Because if he kills this, his queen is dead. So what I'm gonna do, I think I'll probably just put this here to continue defending this. Yes. Let's see what he's gonna play next. If he takes his pawn, then he's dead. If he takes a pawn, he's dead. What are you saying? Bruh, look at this fool. Why why would you play like this, brother? Why would you fumble your queen like that? Why would you fumble your queen like that? Oh my days, this guy is cooked. And I'm gonna kill this defender here. If he doesn't take me, I'll take him, which is crazy. Yo, you may get viewers and support. Donations and all that. I really don't know about that right now, brother. I swear to God. There's nothing is defending. But I'll definitely look into something like that. Like I'm actually right now just busy building my application. Just trying to get it like in the hands of users at the moment. I'm just trying to iterate and just get like more ideas and stuff like that. That's all I'm thinking about really. Well, this is a free pawn. I'm just gonna take this pawn and call it a day. But I really wanted to just get this here. Yeah, I'm gonna have to sacrifice this. I'm gonna have to sacrifice this knight. I mean this, what's the name? This bishop. Yeah, sacrifice this bishop. Good. Good. So now I'm gonna take this pawn first. Oh my god. Why would this guy play like this? He wants to take my queen out of this. Hmm. Alright. Wait. No problem. Yeah, bro. I've lost, man. That was bad. That was bad for me. That was a bad, terrible mistake, bro. But it's fine. We shall cover for it. That was a terrible mistake from me, though. I think I'm going to have to lose this game. You see the time? The time is moving like crazy. All right. Let me just try to kill that pawn. See what's up. I was going to checkmate this guy in a second if I didn't take this. That was bad from me, bruh. That was so bad. So bad. This stuff is not going anywhere anytime soon. So that means all I have to do is just get here and boom. Yeah, what is it doing there? That was, I think that was a mistake. Because if I play here, yes, if I play here, yes. Yes, we are gonna have some ideas, some crazy ideas right now. Let's see. Hmm. Hmm. We are gonna finish this game and go back to we are going back to coding and stuff. Just give it a sec. Let's have some fun, brothers. You should consider liking the stream, my brothers. You feel me? It helps a lot. Helps a lot. Hmm. Why? The question is, why is this guy playing like this though? So I don't want to sacrifice this. I don't want to sacrifice this. Let me play him. Let me leave his pawns looking like mine like this. These are bad pawns. Oh my god, I should have. What is this guy trying to play? Oh, he's dead. He's dead. If he plays what he wants to play, he's dead. Hold on. Let me see what I'm gonna play. Yes. If he plays what he wants to play, he's dead. He's thinking he's checkmating me, but he doesn't know he's cooked. He's cooked. Ah, good one, good one, good one. But guess what though, brother? I don't wanna play there. You know what I wanna play? Here. Let's see. Let's see what he's gonna play. Interesting. Uh, let's see. Hmm. But I can always go here though, so I am not worried about that. I can always go here, so it's fine. Oh, wow, that's crazy. So let me first take that. Mm, okay. Which one should I move? I think this. What's DSA? Data structures and algorithms. Data structures and algorithms. We've been doing DSA, by the way, boys. We've been doing DSA. That's why. But can I just roll this past pawn? Let's see. Damn, I should have rolled the past pawn. We've been doing data structures and algorithms, and I'm supposed to even finish this. I'll finish it in a sec. This chess game is just getting out of just getting out of my. It's annoying me. Let's see. Bro, these guys are annoying me, bro. Like, what kind of fool is this, bro? Bro, this guy is annoying me. I'm not gonna lie. Oh, my mom, this guy is pissing me off. Yes. You're not going anywhere, brother. Good. Okay. Yes. Oh, that was bad. That was terrible, bro. We've lost this game, bro. Oh, let me just resign, bro. This is so annoying, bro. God damn. Shit. We lost this stupid game, bro. Oh. Bro, we lost this game in some dumb way, bro. I hate it, bro. That's not good. Anyways, we continue with data structures and algorithms. We got one problem 167, two sum two. Input array is sorted. Given one index, I think it's one index array. That means it starts from one instead of zero. Numbers that is already sorted in non-decreasing order. So that means it's we are starting with wait, non-decreasing order? That means we are ascending, right? Hmm. That means we are ascending. Find two numbers such that they add up to a specific target number. Let those two numbers be numbers index and numbers index, where one is less than or equal to index 1, less than index 2, and less than or equal to numbers dot length. Return the indices of two numbers, index 1 and index 2, each incremented by 1 as an integer array of this and that. So we need to return the indices of the two numbers. The tests are generated such that it is exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. So let's see what we're going to do. So now we have two numbers, 2, 7, 11, 15. The target is 9. The output will be 1, 2. The sum of 2 and 7 is 9. Therefore, index 1 is 1. I mean, the first index is 1. The second index is 2. We return 1 and 2. The same input here, numbers equals to 2, 3, 4. Target is 6. That means it's index 1 and 3. So 1, 2, 3. So we're starting with 1 and 3 to be 2 plus 4 to give us 6. And the sum of 2 and 4 is 6. Therefore, index 1 is 1 and the second index is 3. We return 1 and 3. Okay, let's see this one too. Numbers -1 and 0. The target is -1. So what's gonna happen? So if we add -1 plus 0, it's gonna be -1. So we are just gonna check 1 and 2. And that is all. So let's see how we're gonna approach that problem. I'm just gonna close this, and I think that is that. Let's try to solve that problem now. I'm gonna just pick one of these. Let's just take this all the way here. Let's grab this and the output. Okay, that is what we're gonna do. Paste this here. This is the two-sum problem. I'm just gonna call this the two-sum problem. The two-sum. I mean, this is a this is a two-sum problem, but the second variation. So two-sum problem, second variation. Okay. So we need to add up to a target. We have this We have these input numbers, uh, zeros, I mean, 2, 7, 11, 15. The target is 9. Yeah, that's a nice question for real, Dakshman. And I want to try to do my best to like solve it. I know we are going to use 2 pointers. That's true. That's like the optimal solution. But let's look at the brute force first to see if we are going to like get an idea. So let's look at what we're going to use here. Let me use green. So here remember the question is saying it should be a one index array. And this is a popular question because a lot of people have liked it. Like 13K is crazy. So uh the first index, and normally arrays they are zero base index, right? They start with zero. But now the question is giving us a constraint of one index. So one, two, just like normal counting, 1, 2, 3, and 4. So now the indices that we need to return to get a target of 9, that means what do we need to subtract from 9? What do we need to subtract within this list to get this target 9? I mean, what do we need to add? What two numbers do we need to add to get 9? But then if you change that entire thing, that expression, that means 9 minus x. I mean, I think it's x minus something, right? We're gonna get something like x plus y is equals to 9. And then the two numbers, we replace them with, like, for example, let's start with 2 as x and then y as 7. So x plus 7, I mean 2 plus 7 will give us 9, and this is true. So now we're returning this is 1 and 2, right? I think that is all. Now, how do we, let's say we want to make y as the subject. Since we already have the first number, right? We usually have the first number. So which other number do we add to y to get 9? So let's try to make x the subject. X the subject or y the subject? I don't know. X minus, I mean, we have x already, so let's make y the subject. That means we need to subtract x from both sides and then make, we go back to 9 minus x. My math is almost running away, but yeah, I still recall it. So y is equal to 9 minus x, 9 minus x, and then we replace it with every x here that we already have. So if we replace it with 7, we are going to get 2. So the number is the first x plus this. So we just replace it with y, and then we get these two numbers, 1 and 2. Now, this problem is not as straightforward and easy. Think about, you can leverage arrays being sorted, not a hint, just what the question said. Yeah, the question is saying that these are sorted in non-decreasing order. That means we are already going to be dealing with, this is already binary search, right? Because this is already binary search, log n, right? Binary search is going to be n log n, which means we can divide these numbers, look at the target, which number among these ones closer to the target. Let's look at this. 2 and 7 and 11 and 15. 9, we have our left pointer here and right pointer. We can use 2 pointers, or we can just like look at this using binary search, and then we divide this into the left and right. So you can see, like, obviously the number that's closer to the target is not anywhere close here, so it's 9. That means let's look at this. Actually, no, not what I was thinking. We need to move this pointer, this right pointer. We say the left is on 2, right? So the left pointer is 2. I don't know if this you guys are getting the point. A left pointer is starting on 2, the right pointer is starting on 15. And then we decrease the right pointer every time. We want to get something that is like better than this n log n binary. Binary is log n, mate. Wait, it is n log n though. Am I lying? I think it's n log n. And not just log n. Binary search is log n, right? But this is like sorted already, so we need to sort first. That's the reason why we have n log n, right? Am I lying? Because we need to sort these so we can get like which half is closer to the target. I think it's from here. We cut it into half. 1, 2, 3, 4. We break it like this. We say, okay, this obviously 9 can be here. So we just get rid of this entire right side. And then we just add these two numbers and then we get it. That is n log n. since we need to sort first and then do the binary search thing. But what I'm trying to do is use the 2 pointers so we don't even have to deal with all of that extra stuff. We have the first pointer pointing at the first number, which is 2. We subtract 2 from the target, right? And then we look at the right pointer and say, okay, now we have 7. I mean, we have 2. We check, is 2 greater than, I mean, is 2 less than the target? Since, I mean, the left side is dealing with increasing numbers. The right side is, let me create it here so you guys can see. Let me create a better box here. So we have 2, 7, 11, and 15, right? Okay, something like this. Cool. Let me put them into boxes so it can just make more sense. All right, something like this. Cool, cool, cool. Then we're going to have here the indices. This is one base index, so one index. We are going to do that. So this is that. And then let's go ahead. I mean, the indices, let me use a different color for the indices so it makes sense. This is 1, 2, 3, 4. All right, let's use what? White for this. So now we are going to have the left pointer on here. And we're going to have the right pointer on here. Now, we look at these numbers. We've already seen that we have 2, 7, 11, and this. So since the numbers are already sorted in non-decreasing order, that means it's in ascending order by default. We don't have to do anything. That means we don't need any extra space. Binary search is log n, and I believe you need to achieve O of n for this question. Okay, yeah, no problem, bro. I think the question, the question is, you can see the constraint here. Your solution must only use only constant extra space. And we can optimize the O of, the thing is already sorted, right? That's why I said that O of n log n is for the binary search. I think, yeah. But if you're saying that log n, I think it's still the same thing though. So what's the difference between O of n log n and O of n log n? I mean O of log n. I don't know if there's any big difference. And if there is, just let me know. It's fine, bro. Go have fun. Go have fun. So let's see. We have the left pointer pointing on 2, dealing with increasing numbers. And this is dealing with decreasing numbers. So if we look at 2 and 7, we have a target which is 9. We look at the target and say, okay, starting from the left pointer, we check, is the current number or the character or the digit in the current left pointer, is it greater than, since you're dealing with wait, I think increasing numbers, we need to check for if is less than. I think that will make more sense. So we check 9, is it greater than the target? I mean, if we're starting from the left, I think we should check for the, yeah, we need to say 2, is it greater than 9, which is the target? Bro, sorting is n log n on average, but binary search, which is don't call it sorted array, has a complexity of yes, that you are very right. You know what? The thing that you didn't get, I was talking about like this scenario. Like this scenario, if the thing wasn't already sorted, if it was not sorted, as you can see, that is already sorted. If it wasn't sorted, that means if we want to use binary search, we would have to first sort it. And after sorting it, that's when we can now go ahead and solve it, right? But you can tell that the solution must only use extra, you must not only, you must use only constant extra space. That means the space complexity should be of 1. That's just what I'm saying. But you're right. Your answer, what you said here is very correct. Since the question gave already sorted array, no need to count for sorting. Yes, yes, that's correct. So we are speaking the same language, but it's just reversed. You understand? So yeah, let's go. We have 2 is less than 9. Yeah, yeah. You just didn't understand what I was saying. So the left pointer, we're gonna say is 2 less than 9. No, that is I mean it's 2 less than 9, that's true, right? So we are not gonna move forward from here. We are just gonna remain here. Now is the work of the right pointer. We check is 15 greater than 9, that is true. Then we reduce it. Come back here, on the right pointer we check is 15 less than 9. No, that's not true. So we continue, we move the left pointer to here. Now the left pointer is here on 11. I mean the right pointer is on 11. Then we check is 11 greater than, I mean less than 9. No, it's not true. Then we return the pointer all the way here. So now the right pointer is already here. Do we check is 7 less than 9? That is true. So add 2 plus 7 and that is the answer. So that is what we are going to be doing. That's what we are going to be doing. And let's see how we're going to try to achieve it, right? So I think this one we're going to say int the left and right. The left pointer is going to start from 0 and the right pointer, where is the right pointer here? Right is equals to since we are dealing with numbers, so we're going to say numbers dot length. Where's G? Numbers dot length minus 1, right? Since we want to get like the right pointer, we need to have left and right pointers. Okay, so now we have these two. Then we have a while loop that is going to go checking if left is less than 9. I mean, left is less than right. Until when they meet, right? That's something I was supposed to explain. We move this one until somewhere where they can meet at least. They will meet on something, or they will just not have anywhere again to go to, and that will be our answer. Okay. I'm gonna say while left is less than right, continue doing something. So what are we gonna be doing here? We're gonna check if. Now this is where we need to check for the characters. So how are we gonna check the characters? So now here we're gonna say numbers. If numbers, I think we're using numbers. Yes, numbers in numbers on the left, right, plus numbers on the right is equals to the target. Is it? Is it equals to the target or the? Hold on, they add up to a target. Let's see. Let's see. No, 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 no. How are we supposed to write this logic? If the numbers on the left, yeah, if the numbers on the left is less than the target, I think that's what we've been doing here, right? The numbers on the left is less than the target, then what are we doing? We if it's less than the target, I think we leave this as is, right? Or we increase it. I don't know. I'm getting a little bit confused right now on the logic. Numbers on the left plus this, they add up to a target. No, we are adding the target. Hold on, we are only adding the target when this reaches here. So let's see what's gonna happen. Let's start with the right first. If numbers on the right, yes, let's say numbers. If numbers on the right, right, is less than the target, then we do something. We say numbers. I mean, we I think we increment the right. We increment the right or we decrement the right. I think the right decrements and then the left increments. Then we check these as well. Yeah, I'm trying to think. I'm trying to think. Like I understood it here, but I'm trying to put it in code, and that's my biggest problem. I usually understand like the problem statement, but translating it into code is always my biggest issue. Let's see. Numbers on the right. If numbers on the right is less than the target, then decrement the right. Decrement the right. Yes, the right pointer. That is okay. And then we do the same for the this, but this we are checking if it's greater, right? Wait, hold on. If on the left is greater, then we increment the left. Yeah, I think. Let's try that out. And if we fail, okay, erase or erase. Numbers on the left greater than the target. If that's greater than the target, we increment the left. Okay. If the numbers on the right are greater than the target, then we increment. If this is, hold on, how are we thinking about it? The numbers on the right, if they are, oh, we've actually changed the entire meaning. If here we check on the right, we say, okay, is the number on the right greater than, I mean, less than 9? So we check 5, 15. Is 15 greater than 9? I mean, is 15 less than 9? Yeah, that's true. We now decrement it. So let's say if numbers on the right is less than the target, no, if the target is less than numbers on the right. So we need to change the expression to if the numbers on the right is greater than the target, then we decrement that. Okay. And then the same applies to the numbers. You remember how you did the classic two sum problem? Yes, 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 with the difference, with the target difference, and then you just add them using a hash map. I remember that though, but this is not, this is like the two-pointer problem. I think we need to use this method. Let me just see. Hold on. Oh, wait. Let's say number less than the target. Then we now choose. If the right is 15, we check is 15 less than 9? No, we decrement. I mean, this is no. We decrement. Yeah. Yeah, so I think that's it. This translates to numbers on the right, are they greater than the target? If it's true, we decrement. Yes, that is true. So if numbers on the left, are they less than the target? We increment the left. Bro, this stuff has messed up my brain. I'm gonna leave it like this. Let's continue. Let's just continue. Um, let's just continue to see what's gonna happen. So Akash is good, bro. Man, I'm going through some shit here. Like this, some hardships. Don't think about two-pointer. Think about binary search. I shouldn't think about two-pointers. Wait. Okay, okay. Dax. Just pay attention, okay, to what I'm trying to do here. I think I'm onto something. I think I'm onto something, right? I think I'm onto something, and I'm trying my level best to get it. So let's just try this one first. If we fail with what I'm trying, like where I'm trying to take this, then we can go ahead and like do it with the binary search. I think, yeah. Oh yeah. Yeah. I'm trying to do the optimal solution because I already like I really don't think doing brute force, like coding out brute force, is not like the best. That's what I've realized, bro. Like, let's say if you're on interview right now, is really like a bad idea to code out the brute force solution unless they ask you like, hey, physically code for us that. Most people are just interested in the optimal solution, but 9 times out of 10, you can just demonstrate to them what like the brute force solution and why it's bad. Then you just go to the optimal solution. Yeah. This is not the two-sum problem with hashmap, bro. First read that question very well. I don't want you to get this twisted. This is not the first two-sum. This is the second variation. Don't get this twisted. You first understand this problem statement. This problem statement is not easy. Okay. If numbers on the right is greater than the target, decrement the right. if numbers on the left is greater than the target, numbers on the left, we check for, let's say we are on the left, we check 2 is 2 greater than 9. No, we do not increment, right? So I think okay, so now here we are not going to have this, we're going to have another, we're going to say else if. Yes, we're going to have if this is true, else if the numbers on the right, so I think we can even use the numbers on the left here now. Else if the numbers on the left are greater than the target, then increment this. Less than the target, then increment this. I don't know, let's try it like this. And then from there, we can have an else statement that will say return the indices. Now we need to return the numbers that add up to the target. Let's say numbers that add up to the target. We need to return numbers that add up to the target. So else, yeah, else we add those numbers, right? I think else we add numbers on the right plus numbers on the left. That will be the target. Is equals to the target. Yeah, this, some people they just read two sum and they say, oh, classic two sum. No, bro, this question is tricky as hell. I've done this before. Oh. Hold on, let me connect this. Okay, let's try to see. Numbers on the right plus numbers on the left is equal to the target. Okay, and oh god. Or else let's try to decrement the right and increment the left. Increment the left. And then what else from here? What else from here? Oh, hold on. Then we return the indices. We return numbers. Numbers here we're gonna have left plus 1. And then since it's one index, we need to add that as well. And left plus 1. I mean right plus 1. Right plus 1. I think that is that. Oh my god. Let's try to run this solution. Uh, yeah. Don't give me the answer. Don't give me the answer. Let me think. Let me think. While left is less than right, if numbers on the right is greater than the target, decrement the right. Let's see. Numbers on the right. If we check, let's take 15. 15. We compare 15. According to our 15 greater than the target, then we decrement. Yes, 15, is it greater than 9? Yes, that's true. Then we decrement the pointer. We take the pointer to now here. Okay, then we check 11, is it greater than 9? That is true. Then we bring the pointer here. Now okay, the right one is working very well. Then we check 7. 7, is it greater than 9? No. So else that's when we are supposed to now add the two numbers now. And then left as well, we check this. All right, I think now let's check the logic on the left. Numbers on the left, are they greater than the target as well? Let's see. Numbers on the left, is it greater than the target? Let's check 2, is it greater than the target? 9, no, false. Yeah, then we just add this. Okay. Else numbers on the right plus numbers on the left. Yeah. Or else Or else return. Should we just return or we just say else just add them? Yes, else just add them. And then continue decrementing the right and continue incrementing the left. And then we just return the numbers, which is numbers, and then we return this should they be like this? This like the index? Are these the indices? Numbers left plus one, right plus one. Did I do it? Hello, bro. Yo. Oh no, hello. Where do we have an error? Where do I have it? Okay, here. Uh oh my god, where's the error? Where's the error, bro? Where's the error? Hold on. You got this, bro. Ultimate gaming. Thank you, brother. Numbers right plus numbers left. What's this? What's this plus? Expected return numbers. Oh, wait. We have error. It's not a statement. Do we just return? Else return. Let's just say else return. Else return numbers right plus numbers left. Oh Lord. Where's the target? I didn't do it, bro. I'm having issues. I'm having errors. Okay, return numbers. Okay. Oh, bro, what the hell is this? Wait. The problem is you added and didn't store it anywhere. Bro, are you giving me hints? I added and didn't store anywhere. Oh, wait. So now I'm already decrementing the right when the number on the right is greater than the target, and I'm also incrementing the left when the number is greater than target. The only challenge is now how do we add 2 plus 7 now? That's the only issue. It's just my error, right? Okay, let me first try to see again. I think error 19 is gone. We don't have any error again in the 19. Okay, so God, we have another statement on 25, right plus 1. Okay, should it be like this? Should it be like this? Oh, yes, I see it now. We need to actually have int. We need to have these empty, because I can see it here. We need to return an array of numbers that is going to store these. So we're gonna have numbers, right? Hello. How I getting this right? Numbers on the left. I think we already have this. Why do we need numbers again? This is gonna be our return type should be like this. Yes. So we need to actually the numbers themselves, which is left. Wait. Let's say numbers plus 1, and then right plus 1. I should create a new array. No, read here, bro. read there. Just read that. Wait, let's run this again. We are not gonna create any new array. Hold on. Let me try to take this. Take this, add this inside numbers, and then probably paste this. No, like this. Hold on. What the hell did I even copy, bro? Okay, numbers left. Left plus 1. Now the reason why we're adding plus 1 is because it's like we started with 1 index, so we need to always add plus 1. And then right plus 1. Are we gonna get this now? Yeah. Now this is where I'm going to have issues. Oh, return new int here, And then we just remove these numbers. Hold on. Oh. Huh? Wait, where am I? Oh, I'm inside the while loop. My bad. My bad, my bad, my bad. Bro, why are you writing? What are this? What's this extra stuff you're writing there? Let's see, let's see. This is outside the while loop. Okay, I just didn't see it. I didn't see it. I didn't see it, bro. What else again? Oh Lord, everything works. We need to remove this return. Let's see, numbers. Huh? Bro, can I get hints, bro? Can I get hints? I think this is fine now. But what's with this? Oh, return numbers these and they should add up to the target, right? Am I lying? Bro, 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 we are close to the solution, bro. Like this, very close. Dax, what's up? Why you mad, bro? Why you mad? Calm down, bro. Wait, bro. So okay, wait. Should we store this? Like, should we need to store these numbers? Instead, numbers is equals to something like this. The target is equals to this. Bro, you guys are not giving me hints, man. You guys are instead trying to attack me. Calm down, bro. Let's not try to run this. Okay, expected this. Fine. I think, is that not the same exact thing I was trying to do? Oh my god, I got wrong answers. This works. Calm down, calm down, calm down. Dax is mad. Why did we fail, bro? I need to know why like all my test cases are failed. The first case, this is now returning two instead of one. Huh, expected one but got two. This is bruh, because the logic is incomplete. Where's the logic? Okay, listen. Let me go through it again, okay, so that I can understand. I've initialized this already, the two pointers, and I'm checking the two pointers. If the numbers on the right greater than the target, decrement. Else, if the numbers on the left is greater than the target, then increment. Else, else the target is equal to numbers on the right plus numbers on the left. I think this should be minus numbers on the left. Um, let's try to run it again. Bro, we're still getting wrong answers. Oh Lord, bro. Okay, let's see how we are doing the target thing now, the addition. How is the target? I say the target is equals to right plus left. So left plus right. Brother, you're just getting indices of numbers which are nearest to the target. All right, boys. See, I'm gonna have to ask AI for some clarifications because for some reason, bro, like your brain can get to a point where it cannot like pick up anything. So don't blame me. You feel me? It happens. It's just that you get it happens to be on stream. I'll give you a hint. Okay, give me a hint. Make me understand what's going on. Okay, before we go to AI, make me understand what's going on. Oh my god. One at the beginning and one at the end. Is this not we have? Is this not what we are doing though? We have one at the beginning and one at the end. Oh, so this one doesn't do anything. We just decrementing this. Bro, I think we figured out like the increment and decrementing, remaining just how to get the target. And that's why I'm having this issue right now. Don't compare direct numbers, compare sum and target. Wait, I'm comparing this numbers, sum and target. Don't compare direct numbers. So wait, the addition of these two numbers is equal to the target. So we need to get the sum. Huh. Okay. Now, which one should we say? Bro, I get you, bro, but I'm not getting nothing. Like I'm understanding what you're saying, but I don't know how it's applying to this code that I'm writing right now. Like on which line? You mean in the else statement here? Oh my god, you guy. I'm confused, bro. I'm confused. Hold on. Why is this still behind? Okay. All right. Let's go back. Okay. Come. Come. Akash. Let's play some chess. 10 minutes game. Let's send that. Alright. Uh, mm, 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 mm. Why would you do that, oh boy? Hmm. Interesting. Hmm. Hmm. Where can we put this? Okay. Let me play. Interesting. All right. Mm. Check. He's gonna have to kill me. Kill him. Yes. Wait. I think I'm gonna just take him back. I wanna take this back. Hmm. Mm, mm, mm. Mm. Let me see. What else do I have here? Which one that I have played? What if I played here? He was gonna take me side. Yes. Mm. Put it all behind me. Hmm. Interesting. This guy's cooked. Easy. What am I gonna do? Right? He's gonna take my queen anyways. So I might as well just go with check up there. Yes, check. Yes, fair enough. Ah, why did I play like that? Oh, okay. Oh my god, this is checkmate, bruh. This is checkmate, bro. Shit. Oh my god, I messed up. I messed up, bro. Shit. I don't know, bro. Like, what could I have played? Oh my god, bro. What could I have played, bro? Like, you put me in some crazy situation. Wait, was that bad? Because let's say I played somewhere here. Oh, you're still gonna take. So that wasn't good. What if I played something like this? Let's say something like this. Then you are still gonna take as checkmate. Yeah, that was bad. I should have removed this earlier. It's all good, man. It's all good. Good game, good game, good game. You played, my boy. So let's see YouTube. Mm. You played, bro. Let's go back to solving the problem. I don't know about the problem, bro. There's some let me try to cook, brother. Think like this. Okay. Uh-huh. Let me wait. What are you saying? Add first and last and see if it's less than the target. Mm. Okay. Oh, wait, else? Hmm. Okay. Else numbers on the left. I think we're starting with the left plus numbers. Oh my god. What am I doing? Where's plus? Good. Numbers on the right. Check if they're less than the target. See it's less than the target. Plus numbers on the right. Less than the target. Is that okay? What are we doing? I think we can say sum. All right, hold on. Let me first try to see here. What is this? Numbers on add first and last, and see if they are less than the target. Do we need a return statement? But the problem is just here. Do we need a return statement? I don't know, bro. Like, I think else needs a return statement though. Else return this incompatible type boolean converted to int. Okay, number is this. This. Oh, can we check else? Return if I think we can check here if numbers. Wait, numbers on the right is plus this greater than this return the target. I don't know. I don't know, bro. Like my brain is just clogged up. I think it's time to just let AI clarify this issue for me. I'm not gonna lie. I think that would make it easier, and then yeah, that will make it easier for me. That's what I have a hard time like understanding things like this, especially when you're just typing. At least if you're talking, I'm gonna have to let AI explain to me why there's a problem. So I'm just gonna say I'm currently stuck in understanding the logic for getting like the target. So could you explain to me why I'm not getting the actual answer? All right, first, wait, listening, transcribe. Okay, let's see. Your correlation is fundamentally broken in a few key ways. You're comparing individual values to the target. Numbers on the right greater than the target. This is incorrect. The problem is about sum of two numbers, not a single number. So numbers on the right greater than the target, it might be valid when paired with a negative or small number. So numbers on the left plus numbers on the right. This line does nothing. Numbers left plus this less than this. This is just Boolean expression. You move both pointers blindly. All right, so the correct one, correct model, this is the key. At every step, sum is equals to numbers left plus right. So this is what is going to work. Okay. We need to initialize the sum. And sum is equals to because the other thing, oh my god, the classic two sum problem, we need to initialize the sum, okay? And sum is equals to numbers left plus right. And if sum is equals to the target, return new int left plus one, right plus one. Else if sum is less than the target, increment this, else decrement the right. Fallback shouldn't happen. Wait, is that even okay? Is that even correct? Okay, so sum is equals to the target, or if the sum of these two numbers equal to the target, return new int left plus one, right plus one. That's correct. Else if the sum is less than the target, then go ahead and so the sum, this is like this two sum problem. Okay, else we decrement the right. So if the sum is less than the target, we we increment the left, need bigger sum. Right, we decrement this, we need smaller sum. And then we return negative one, that's the fallback. That shouldn't happen. Or we can just return an empty string or we return null. Okay. Now I get it. Now I get it. This is our problem here. The way we're thinking about it is the problem. So that's fine. We're gonna have int sum is equals to um numbers on the right plus numbers on the left. Oh my god. Damn. Okay, then we need to just check if the sum is equals to the target. The sum is equals to the target. Then we go ahead and return this. What is this? We return this, or else we just return null. So we return new. Take this. We return this, or else we just return null here. Because negative one won't make sense. So we're just gonna return null. Else if the numbers, if the sum is, if the sum is less than the target, We increment this. That means we need bigger sum. Then we increment the left. Else we decrement. This is else if the sum is less than the target. Do that. Or else we just decrement the right. Decrement the right. That means we need a smaller sum of two numbers. Okay. All right, all right. So, oh, these ones, we actually supposed to move them as pairs. That's the problem. I was thinking as like individual left, right. But these ones supposed to move as pairs. Almost like these pairs, they're moving together. These pairs are moving together. This, okay. Okay, 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 okay. Oh my God. We need a bigger sum. All right, I think that's it. We remove this, or else we just return null. Okay, I think my solution was having some issues. What's going on here? New int without the return statement. Okay, return. Let's go ahead and return. Oh God! Oh my God! With the help of AI, we were able to kill that question. Fundamentally, this problem is tricky as heck. This problem is tricky as hell. So I'm just gonna submit this problem. Uh, we have passed. That is okay. But I'm gonna tell AI to explain to me why I had issues. So simple intuition, no jargon. Start from both ends. Check the sum. If too small, move left up. Oh, now I understand. Instead of like having 2, 7, 11, and 15, instead of having left and right, we are just gonna start from both ends. We are just gonna start from both ends. And these two will check, right? First, start from here. What numbers are we going to add? We check 2 and 7. 2 plus 7, we check their sum. We check this. This is going to give us the sum, right? So the sum here will be 9. Obviously, this is just going to give us the target. And then if this sum here, target, if we check if it's greater than, if it's less than the target, if the sum is greater than, it's less than the target, then what are we doing? We are incrementing the left. All right, let's see. If the sum, is equal to the target, we just return the answers here. Else, if the sum is less than the target, we increment the left. We need a bigger sum. So that means we move the left pointer to here. That now we need to start counting 7 and 11. Because we've already seen this, we don't have to repeat it. So we're going to have to add 7 plus this is going to give us 18. Then we check again the sum. Sum of two numbers here, are they greater than or less than the target? Okay. Okay. Now I understand it. I get it now, boys. Oh my God. I had a hard time trying to understand this problem, bro. So I think that is going to do it for today's stream, my boys. We are done with this problem. I'm just gonna go here. That's okay. Tomorrow we shall do the three-sum problem. Container with the most water, trapping rainwater. After that, we can go to binary search, sliding window, linked list, and all that. So I think that is that, my boys. Let's go to the description. We've submitted that. That is okay. Let's just do it on neat code just so that we are not confused by that again. So first, within this while loop, we need to initialize the sum. Int sum is equals to sum is equals to numbers on the left. plus numbers on the right. If the sum is equals to the target, then we just return the numbers. Return new int. New int, we're gonna have left plus one, right plus one. Else if the sum is less than the target, else if the sum is less than the target, then we increment the left. That means we need a bigger sum, and else we just decrement the right. Remove the pointer from the right. And finally, out of this while loop, we just return null. Let's go ahead and run this. We've paused and submit it. And that is that. Now let's visualize this code and see. Neatbot. Oh, neatcode.io has neatbot. Now this is clean. Okay. Two target technique. Okay. We'll put it on 0.0. Can we expand this? Let me maximize this neatbot. And let's visualize it. Left, right. Okay, let's take it to point this and let's run it. Initialize the left pointer to the start of the array. Wait. Let's move here to the first stage. We first wait. The target is 3. We have 1, 2, 3, 4. We have 0, 1, 2, 3. We have left and right. Initialize the left pointer to the start of the array. This is 0 base index. And the right pointer to the end, index 3. Okay. Next. Calculate the sum of the numbers in position 0 and numbers in position 3. Calculate the sum. So we have 1 and 4. Now we need to calculate the indices. 1 plus 4 is 5. The target is 3 though. So we need to check the sum 5 is greater than the target 3. We need a smaller sum. So we move the pointer to the left. We move the right pointer to the left. Yes, right pointer move to index 2. Then now we have 1 and 3. Then we calculate the sum of numbers 0 and numbers 2. That is 1 and 3 is equals to 4. So that's the correct answer. The sum 4 is still greater than, oh, it's still greater than 3. Decrement the right pointer again. Decrement it again. Right pointer move to index 1. So we have 0 and, we have 1 and 2. Now if we add 1 and 2, we're getting 3. And that's the answer. Calculate the sum of the numbers. 1 plus 3. The sum 3 matches the target. We return the 1 index position. That is going to be 1 and 2. So 1 index position is 1 and 2. That's cool. God damn, this neatbot is lit though. What is it using for solving these problems? Wow. Neatbot is fire, dog. I feel like this thing that I've introduced on Neatcode is just so nice. Oh my god, I'm impressed. I swear I'm impressed. I'm impressed by this, bro. How did it do that? They're using AI. So they have a Neatbot. Okay, so I think that is gonna do it, my boys. I'm gonna have to end this stream here right now. So I'll see you guys tomorrow, man. Let's get it.